Hi everyone, my name is Riley Talbot and this presentation is about projectile motion in basketball. Projectile motion refers to the type of motion experienced by projectiles traveling through the air and ignoring air resistance. It is an example of linear kinematics where we know what changes in velocity and acceleration there will be once an object or body is released. A basketball relates to a projectile as the force exerted upon the basketball is a push. The basketball is then projected horizontally and vertically, causing, if the proper shooting technique is applied, the basketball to rotate, elevate, and finally swish through the net. The horizontal and vertical components are both independent and therefore do not affect each other. The arc caused by the basketball is a result of the gravitational pull upon the basketball, and if the basketball was thrown without that pull acting upon it, the basketball would travel continuously without arcing, which relates to Newton's first law. A simplified way to explain the perfect arc of a ball when shooting it is the distance between the release point and the height of the ring should be doubled for the height of the ball, so on the y-axis, and by the time the ball reaches halfway from the release point towards the net horizontally, it should be at its peak, as displayed in the diagram there. If there's a 3 feet distance between the release point and the ring on the y, then there should be a 3 feet distance between the ring and the maximum point of the ball. As seen in this photo, the right arm releasing the ball is pulled back at about a 90-degree angle between the forearm and towards the wrist, and then the wrist is also locked backwards with the ball resting on it, both prepared to perform their lever action to release the ball. Once released, the ball seen here is at its peak about halfway and does follow that arc and goes in the basket.